Ciao, amici di Accelerated. We are moving on today with our learning of factoring. At this point, you're going to be like, how many ways are there to factor? A lot. There are a lot of different ways to factor. So what we've learned so far, as a recap, we've learned about taking out your greatest common factor. We have learned about the difference of two perfect squares. We have learned about perfect square trinomials, but really what we really care about is just factoring trinomials in general, which is what you learned last class, was how to factor trinomials. But not just any trinomials. Remember that we were talking about trinomials that did not have a number that we could see in front of x squared, because the number that's in front of there is actually 1. So this, from last class, was when a equals 1. And factoring by splitting is what we call our factoring process for trinomials. Remember that trinomials means that there's 3 separate terms. So it's when we factor trinomials when a does not equal 1. So that's what these notes are about. So if you're trying to organize your notes, your 1.3 factoring notes were about when a equals 1. Today is about when a does not equal 1. So last notes we talked about this situation where this guy is factorable if and only if there exists, which is your backwards E, if and only if also has a shorthand IFF. Just so you know, and you'll start seeing it throughout class. There exists 2 numbers where their sum is B and their product is C. And I'm here to tell you that that is true also for this guy, except for now, if and only if there exists 2 numbers whose sum is B, and actually it's that their product is A times C. So if you take A and multiply it together, that's the product we want to equal to. And then you take those 2 numbers and then also sum them, and it should get to B, which is also what this rule up above was, because technically A was 1. So it was just C times 1, which is just C. So it's the same rule. It's just it was kept simple before, and now you know the full truth. So the full truth is that if we want to factor something where a is not 1, I'm going to create this little x guy, and I'm going to do positive 5 here. Instead of just doing 3 down here, now I'm going to do 2 times, got a little ahead of myself, 2 times 3, which is positive 6. Okay, so now we want 2 numbers that multiply to 6 and add to 5. You can make your list of variables to the side. We want them to add to 5, which means that we've got 2 and 3. Now what we do, instead of going straight into our factored pieces, we have to split open the trinomial to make it into 4 terms. We have to uncombine like terms. What you need to do is you need to do 2x squared plus 2x plus 3x, and then finish it plus 3. So I took these 2 numbers, because this needs to be plus 2 and plus 3, okay? I took these 2 numbers and separated out 5x into a sum of 2x and 3x. You do not have to have it in this specific order. It can be 3x plus 2x. That is also fine. It just might look a little bit different if you go through the process with me. Okay, so first we just split the trinomial. Next, we take out your greatest common factor. So I look at this guy and I look at this guy and say, what is my greatest common factor with each of them? So you need to take each of those split pieces and find their greatest common factor. So this greatest common factor between these 2 terms is 2x. What is left is x plus 2x divided by 2x is 1. I was too emphatic about that. Plus, the greatest common factor between these two guys is 3. And what's left is x plus 1. The beautiful thing that happens here is every single time you do factor by splitting, these two guys should always end up being the same. If they're not, then the third and last step, which is actually a repeat of the second step, won't work because you need to take out your greatest common factor again. And in this case, your greatest common factor between these two guys is x plus 1. So if you take it out, you're left with 2x plus 3. Okay, and that is your final answer. That's how you factor when a is not equal to 1. You could always double check by foiling it out and combining like terms. There's always a way to double check. So that is a great security blanket for when you're in a test and you're like, I think this is the right answer, but I don't really know for sure. Go ahead and FOIL it out, combine like terms, check. You can always check. Okay, now it's time to practice. We've got this going on, so I'm going to find two numbers that add to 19. I know it needs to add because this number right here is positive. If this number is positive, then that means that the two numbers need to add to the middle term. Now, the two numbers that need to be multiplied are the 6 and the 10. So I want to find two numbers that multiply to 60 and add to 19. This is where creating your little factor combination to the side might be really helpful. Just really quickly, 1, 60, 2, 30, 3, 20, 4, 15, 5, 12, 6, 10, 7, 8, 9, and that's it. So we're looking for two numbers that add to give us 19, and that's going to be 4 and 15, plus 4 plus 15. Now, the first thing that we have to do here is not immediately split it into two parts, which I'm sure you were kind of like on your seat ready to do, maybe some of you, maybe not. What we want to do is we want to split the middle term. So we're going to do 10x squared. It does not matter whether you do plus 4x or plus 15x. It just means that your greatest common factor might be different than my greatest common factor. I would recommend doing the one that I'm not doing right now and see if you get the final answer the same as my final answer. And so then that way we can kind of work through it together. I am going to do 4x plus 15x plus 6. Again, I'm just taking that 19x and splitting it apart. Again, I would like to challenge you to do 15x plus 4x on your own and see if you can do it. I'm going to look at now the two halves of my splitting and find the greatest common factor. The greatest common factor that I have here is 2x. What's left is 5x plus 2. The greatest common factor here is 3. What's left is 5x plus 2. That's a nice breath of relief, like a nice sigh of relief that I get the same answer here, which means now I can take out the greatest common factor again, which is 5x plus 2. And you're left with 2x plus 3. And you're doing it. You're factoring trinomials where a is not 1. I would like you to try this next one on your own. We are looking for two numbers that add to 13. We know it needs to add because this guy is a plus, and then multiply to give us 12. You can make your list of factors to the side. The answer is plus 12 and plus 1. I'm now going to split open that middle term. Greatest common factor is 3x. There is no greatest common factor here, which means the greatest common factor is 1. So you should write plus 1 and then do x plus 4. And that way it might be a little bit easier for you to see that all you need to do is next take out x plus 4. And you're left with 3x plus 1. Okay, next one. We are looking for two numbers that subtract to -5, subtract because this guy is negative, and multiply to -6. So we're looking for a difference of 5, not an addition of 5. 6 here can lead to some really tricky situations and a lot of mistakes, because I think a lot of people will jump on the bandwagon of saying, oh, 2 and 3. But that's not the case, because 2 and 3 do not have a difference of 5. They have a difference of 1. So since we want a difference of 5, we know that only this guy will have a difference of 5. So we want to have 1 and 6. One of them needs to be positive and one of them needs to be negative. How we know which one's positive and which one's negative is that we want a -5. Which means we have to have +1 and -6, because 1 minus 6 is -5, or -6 plus 1 is -5. Next, we split open our middle term. Does not matter which order you put it, because you might get different greatest common factors, but you'll still get the same final answer. Again, take out your greatest common factor, which is x minus 2 in this case, and your final answer. Okay, go to the back page, and we're going to do the rest on our own, and I will go through the answers just really quickly for every single one with you. For D, we want two numbers that subtract to 9 and multiply to 36, -36. I might make a list of my factors to the side: 1, 36, 2, 18, 3, and 12, which I can stop there because I know that that has a difference of 9. We want it to be a positive 9, so it needs to be +12 and -3. So I do 2x squared plus 3x plus 12, minus 3x plus 12x minus 18. And then I take out my greatest common factor. And then I take out my greatest common factor again. And now I am done. For E, we want two numbers that add to -25. Add because this guy is positive. We know that both of them are going to have to be negative because this guy is negative. And then 6 times 25 is 150. So we want them to multiply to 150 and add to 25. This guy, I'm definitely going to make a list of factors to the side. For a second, I was like, oh, that's going to go to 25, and it won't, because it'll subtract to 25, and we want them to add to 25. And there we go. 10 and 15. Sometimes it's really obvious, and you kind of kick yourself for being like, oh, yeah, that was obvious. So -10 and -15 will help us split up that middle term. 25x squared minus 10x minus 15x plus 6. Greatest common factor,